Let's talk about using a system of linear equations to solve word problems. First example, let's read one sentence at a time, make sure we understand everything. Connie has been hired by Gillette Enterprises and she receives an annual salary. Wait a second, what does that mean, annual salary? So annual salary means how much money you make for a whole year. Most teachers have an annual salary, so they have a fixed number that they make for the year. And if they do something like coaching or take home their marking, they work extra hours, they don't get extra for that. But also if they stay at home, take a few sick days, they don't lose money for that. So the amount of money they make over a year, generally, is a fixed number. So an annual salary, as opposed to what a teenager might do if they're working for like a fast food restaurant, they're probably getting paid minimum wage. That's an hourly wage. That's based exactly on how many hours you work. So Connie gets an annual salary of $32,500. That's her flat rate per year, but she also gets an extra $500 for every year she's worked for the company. So if she's worked for them for 2 years, she's going to get an extra $1,000. Ruth has been hired by William & Sons and receives an annual salary of $28,000. That's less than Connie, but she gets an extra $1,000 per year of employment. Create a let statement for the variables you will use. So we are obviously going to be coming up with a system of linear equations and we need some variables. What are the variables? The easiest one to find first is if you can find the word per anywhere in there. Now, this sentence doesn't have a per in it, but it kind of does if you think of it. It says an extra $500 for each year. That could be $500 per year. And it's right here, $1,000 per year. So as soon as you find that word per, whatever's after it usually is your independent, your x. So in this case, our x would represent the number of years. But we're going to just use other letters this time just to give you some experience with that. Instead of x, we'll use n for number of years. What's the other variable? What's dependent on that? Well, what is dependent on that is the amount of money they're making. So their annual salary is based on this number plus this extra number. So n is going to represent the number of years worked, and we'll let a represent their annual salaries. Write an equation to represent Connie's annual salary. Connie makes $32,500 a year. Let me highlight that. She makes $32,500 a year plus an extra $500 for each year. So putting that together in an equation. Now, if we were using x and y, we would have, remember, we would have the 500 and then we would have the x after that, but we're using n instead of x. So Connie's salary, her annual salary is equal to the flat rate. This is the flat rate here. This is her annual salary. And then this is the 500n is the number that's changing every year. So that's why it's your slope. If we had y equals mx plus b, y equals mx plus b, it would look like this. So if 32,500, if you want to use x's and y's and write it out that way, you can. A lot of us are more comfortable writing in the form y equals mx plus b. You could write it out that way. Now Ruth, same thing. It's going to follow the same format as this one. So look up to the information about Ruth, and what's her equation going to be? Press pause and write it down yourself. Here it is. Her annual salary is $28,000. That's her flat rate, and she's getting another $1,000 every year. What will the point of intersection mean for this linear system? When you see this question, it doesn't mean define point of intersection. So you wouldn't say it's where the lines cross. That's not what you're doing for a word problem. You're actually describing what does it mean. Now normally we would have an x and a y, and we would be saying what does it mean when x and y are the same in both. For our question though, instead of x we have an n, and instead of y we have an a. So I want to know when this coordinate is the same in both equations, when n is the same and when a is the same. So what does n stand for? Look up again at our variables here. N is the number of years worked. So when we have the same, when Connie and Ruth both work the same number of years, whatever that may be, maybe it's going to be 2 years, at that point they'll have the same salary. The point of intersection represents at what number of years worked both Connie and Ruth will have earned the same annual salary. So same, the N and the A have to be equal in both. After how many years will their salary be the same? So let's figure this out. How long will it take for them to make the same salary? So we've got two equations here. I'm going to label them 1 and 2. And we've got a couple of methods. We've got substitution and elimination to choose from. And part of the title in today's lesson is substitution, because what we're going to do, since A is already isolated, remember substitution is best used when one variable is already isolated. A is already isolated there. It is here too, but we only need in one. So we've got A isolated here. So I'm going to take this whole piece here that is equal to A, and I'm going to, instead of having A here, I'm going to write this stuff there. So that's the method of substitution. So I'll take what I put a box around there in blue, and I'll write it first. 32,500 plus 500 N. That's going to equal, so equation 2 is 28,000 plus 1,000 N. So now we have to solve for N. Now if you used X's, then instead of N's you have X's here. The first thing I'm going to do is collect my like terms. I will collect the variables first. So I've got an N here and an N here, and I want them both together on one side. I can either subtract 1,000 N and bring it all over to the left side, or I can do the opposite. And I'm actually going to do the opposite because it's usually a little easier to have a positive coefficient. So I'm going to bring this 500N over here, and I do that by subtracting 500N from both sides. 500N. I now have 32,500. These are gone, equals 28,000, and 1,000N minus 500N is 500N. Now I have to collect my constants. They're going to go to the other side, so I'm going to subtract 20,000. And you could do this in, you could have done all this in one step at the beginning. I'm just not going to skip any steps. I'm not going to do two steps in one. So I'm going to take 32,500 and subtract from that 28,000. What do you get? You get 4,500 equals 500, these are gone, 500N. Now I need to divide both sides by 500. Divide by 500. And we have N isolated now because these 500s cancel out, and we get an N value of 9. What does that mean? N is 9. So what was N again? N represents the number of years worked. Okay, so when Connie and Ruth have worked 9 years, when they've both worked 9 years, they're going to be getting the same salary. So after how many years will their salary be the same? So let's do a therefore sentence to go along with that. Therefore, after 9 years, their salaries will be the same. And we've answered that. After how many years will their salary be the same? 9 years. And what will their salaries be? How much money are they going to be making? They're both going to be making the same thing at 9 years. They're going to make the same amount of money. So how do we figure that out? Remember, for any time we're solving a linear system, solving for one variable isn't enough. We need to solve for both. So we now know what N is. So I'm going to go back. Let me erase some of this stuff up here. I'm going to go back up to my equations, and I'm going to find A. And to find A, I'm going to sub N equals 9 into, what equation do you like better, 1 or 2? Let's take 1. Equation 1 was, always go to the original equation first, 32,500 plus 500N. Now instead of N, we just figured this out. We know that N is 9. I'm going to put that in. 32,500 plus 500 times 9. Okay, keep going here. So now you just have to do 500. We're almost done. 500 times 9. That's 32,500 plus 4,500. Now we add them together and we get 37,000. So I'm going to add on to my sentence over here. After 9 years, their salary will be the same. And what will their salaries be at that time? So let me erase, no, go to purple. What will their salaries be at that time? Their annual salaries will be $37,000. So before 9 years, one of them, Ruth or Connie, one of them was making more money before 9 years. Then once they got to 9 years, they were tied. Then after 9 years, the other one pulls out into the lead. That's how a point of intersection works, right? If you have one line here and another line here, and let's say our point of intersection is right here, there's always one line below the other, and then it switches at the point of intersection. So if Connie was making less money, then at 9 years they were making the same amount of money, and then at 10 years Connie would have been making more money if she was making less before. So it always switches. So that's what we have found here. Example 2. Two tourists, Charlie and Tom, are in separate hot air balloons rising over Toronto. Charlie's balloon is 10 meters above the ground and rising at 15 meters per minute. Tom's balloon is at 30 meters above the ground and rising at 10 meters per minute. So you need to understand everything going on in this problem before you go on to start the question. So here are some hot air balloons. This actually is a light bulb, but they're supposed to be hot air balloons there. First, we're going to define our variables. And when you get stuck on what am I doing for variables, usually it tells you in the question. So if you read on a little bit, here it tells you write the equation to represent the height of Charlie's balloon over time. So this part of the question is actually giving us a clue. It's telling us the variables are height and time. So that helps me to figure out my variables, my unknowns. But of course I can look for that word per again, and there it is, 10 meters per minute. That means minute is going to be my x, or my independent. So we've got, let m represent the number of minutes and h represent their height above the ground. Write an equation to represent the height of Charlie's balloon over time. So now would be a good time to press pause and see if you can get this on your own, but I will show you. So his height over time, so here's Charlie here. Charlie's balloon is 10 meters above the ground and rising at 15 meters per minute. So this is the part that gets the variable attached to it. So this is going to be the 15x or the 15m in this case for minutes. So 15 meters per minute, the m is minute, not meters. And then this number is kind of like the flat number. It's 10 meters above the ground, and this is how fast it's rising. So the equation for Charlie's balloon is 10 plus 15n. And you can follow that pattern for the next one. Tom's is going to be the same format. The height of his balloon, so he's at 30 meters. So this is the initial height is at 30 meters. So say somebody is standing on the ground and they've got their stopwatch and they're recording this. And the moment they start, Tom is 30 meters above the ground in his balloon, and Charlie is 10 meters above the ground in his balloon. So these are our starting values here. They're our initial values. They don't have a variable attached to them. They're the y-intercept. So Tom, his height is starting at 30, and then he's climbing at 10 meters per minute, and the m is for how many minutes. So if he's climbed for 1 minute, well, then he's at 40 meters high. What will the point of intersection represent in terms of this word problem? Again, you don't say the point of intersection means where the lines cross. That's not what a word problem is asking for. So what does it mean? What does it mean when the h and the m are equal to each other in both equations? The point of intersection represents the number of minutes, so the amount of time since departure, that the balloons will be at the same height. So the amount of time, the amount of minutes, actually it's not since departure, it's since the person, whoever's on the ground is watching this, it's since they started. So after how many minutes? After 5 minutes, after 10 minutes, after 3 minutes, after how many minutes will the balloons be at the same height? So what time will they have the same height? And now we're going to determine the point of intersection of this linear system. To do this, again, h is already isolated in both, so I'm going to use the method of substitution. Method of substitution is best, so I'm going to take this first this is all equal to h in the first equation. This is the same as h because it says h is equal to that. So I'm going to put it in here for this h. So down below, I'm going to take the part that I wrote the blue box around. That's 10 plus 15m, and that's equal to the red equation that's underneath it, 30 plus 10m. And why don't you press pause and finish the question yourself, and then when you come back you can skip ahead and look at the answer. Okay, I'm going to collect my m's first, and I can put them on whatever side I want. I tend to put them on the side that will make the number in front of the m positive, meaning if I subtracted 15m, I'm not going to, but if I subtracted 15m here, then I would end up with a negative 5m on that side. And that's fine, but it's just a little easier sometimes if you can have your variable be a positive instead of a negative. So instead of doing that, I'm going to bring the 10m over to this side here by subtracting 10m from both sides, and that allows me to have a positive coefficient in front of my m. So my equation is now, I've got this 10 here, and now I've got 5m, 15m minus 10 is 5m, equals 30, and then these become 0. Now I've got to subtract 10 to bring the constants together. That gives me 5m equals 20. Okay, and now I have to see, I have a positive 5 here, so it's a little easier. I'm just going to divide by a positive 5 instead of having to divide by a negative 5. Divide both sides by 5. Those cancel out, and I have m equals 4. So what does that mean? It means that when m is 4, okay, what's m again? Look up to your, m is the number of minutes. So okay, at 4 minutes, the balloons are going to have the same height. So let's write a sentence for that. So at 4 minutes, the balloons will have the same height. Now the question says determine the point of intersection. So I don't have it yet. I only have what m is. So at 4 minutes, they're going to have the same height, but what is that height going to be? How do we figure out what that height is going to be? We need both h and m for this question. So now I go up to either equation up here, and I'm going to solve for h now that I know m. Last time we used equation 1, so this time we'll use equation 2. We're going to put sub m equals 4 into here. Sub m equals 4 into, and we'll take our second equation this time. So this was 1, this one is 2. The equation was h equals 30 plus 10m. And in for m, I'm going to put 4. So I get h equals 30 plus 40. H equals 70. So that means I'm going to actually add this onto my sentence here. At 4 minutes, the balloons will have the same height, which is 70 meters. And the question asks for the point of intersection, so I'm going to be really clear with that. Therefore, POI, point of intersection, is, now remember which one goes first. Am I putting the H or the M first? Well, look up at the equations here. Which one would be the same as the X? That would be this one here. So M is my X. So I have to put the X first. So instead of X and Y, I have M and then H. And my M is a 4 and my H is a 70. And that's how we solve word problems that require a system of linear equations.